In this video, we're going to learn about the concept of ions. Ions are atoms that have a charge. And what's important is that the way they get that charge is by either losing or gaining electrons, not protons or neutrons. So if you look at this example over here, we have a sodium atom. And here we have the sodium ion. What you'll notice is that to go from the sodium atom to the sodium ion, it lost this outer electron here. And so because it lost one electron, it became positive by one, positive one. Because electrons are negative, when you lose them, you become positive. So if you lose one, you become positive one. If you lose two, you become positive two, so on and so forth. Here you have the oxygen atom, meaning there's no charge yet. And it becomes the oxygen ion that we call oxide. So you'll notice that to become the oxygen ion, it gained 2 electrons. And so by gaining 2 electrons, it became 2 minus. So a element can become a negative ion by gaining electrons. Because again, electrons are negatively charged, so when you gain them, you become negative. Negative 1 if you gain 1, negative 2 if you gain 2, so on and so forth. So cations, that's the word we give for positive ions. Positive ions. So ions are charged atoms. They can be cations, which is a positive ion, or they can be anions, which is a negative ion. Cations, to remember that they're positive, you can look at the little T in the middle, it looks like a plus. Or you can say cats are cute and positive. Anions, there's an N here, stands for negative. A negative ion. So cations form by losing electrons, one or more. So for example, sodium lost 1 to become sodium plus 1. We don't have to put a 1 if it's a 1, we can just put plus, but if you want to for now, you can put a 1. And anions, they form by gaining 1 or more electrons. So oxygen gained 2 electrons, it became O2 minus. So what's the point of forming ions? Ions really form when compounds are forming. So when two or more elements are combined together. And the whole reason that happens is because the element or the atom wants to be as stable as possible. And the most stable elements are the group 18 elements, the noble gases in group 18. So if you go to your periodic table, you'll see group 18 over here. And you might remember from grade 9 that the group 18 elements, noble gases, they have 8 valence electrons, or 2 for helium. So they have a full valence shell. And remember, the valence shell is the final shell of electrons. And so that is what makes them stable. So elements want to be like the noble gases. And there's a few ways they can do that. They can do that by losing or gaining electrons, and they can do that by sharing electrons. When you become like a noble gas, we say you have what's called a noble gas configuration. It means an atom that now has a full valence shell, just like a noble gas. And as I mentioned, some elements become like noble gases by losing or gaining electrons, so forming ions. So metals, they usually become like a noble gas that comes after them, or comes before them. By losing 1 or more electrons. So for example, lithium, if we go to our periodic table over here, lithium is going to lose an electron. And when it loses an electron, if you think about it, it has 3 electrons right now. When it loses 1, it's going to have 2 and become like helium. So metals, they go backwards. And they lose electrons to become like the noble gas that comes just before them in the periodic table. But for nonmetals, it's the opposite. Nonmetals, they're going to gain electrons. And when they gain electrons, they're going to become like the noble gas that comes after them. So if you look at, let's say, fluorine. Fluorine is going to gain 1 electron and become like neon. Oxygen would do the same thing, but it gains 2 electrons to become like neon. Nitrogen does the same thing, but it gains 1, 2, 3 electrons to become like neon. So nonmetals gain electrons to become like the noble gas that comes after them in the periodic table. And we'll learn more about why that is in just a bit. Some other elements can just share. So instead of forming ions, they share. So if you look over here, oxygen and 2 hydrogens, they'll come together and they'll share their electrons here so that together they have a complete set. So oxygen had 2, 4, 5, 6 of its own, and then it's shared with this hydrogen, so now this technically 7, and then it shares with this one here, so that's now 8. So oxygen now has 8 valence electrons when it's sharing, and the hydrogens are happy too. They have, this one had 1, but now when it's sharing it has 2, and that's okay for hydrogen because hydrogen only has 1 shell, and the first shell you can only have 2 anyways, right? Remember the rule for now is 2, 8, 8, like you learned in grade 9 chemistry. So here we can see elements losing and gaining to form ions, cations, and anions. And here you can see elements sharing. Either way, it ends up with a full valence shell to become more stable. So we're going to continue with the idea of ions and see how we can predict the charge that an ion can have. So how do you determine the charge of an ion? The number of electrons an atom must lose or gain in order to have a stable octet. That basically means a full valence shell or full valence shell. Octet means 8, so 8 makes it stable, which basically means a full valence shell. Right? Remember, valence shell is the last energy level, the last shell. So as we mentioned, nonmetals will usually gain electrons, so nonmetals tend to form anions. They gain electrons, whereas metals tend to form cations, meaning they lose electrons. So we'll take a look at an example, 2 examples. We'll look at a nonmetal and we'll look at a metal. And then we'll do some practice problems. So here we have the element sulfur. The reason I know this is sulfur is because you'll see there's 16 protons. And if you look in your periodic table, 16 protons is sulfur. If you draw a Bohr-Rutherford diagram, you would have also 16 neutrons and then 16 electrons with 2 on the first shell, 8 on the second, and 6 on the last. And so you have to ask yourself, is it easier to gain 2 on this last shell to get to 8, or to lose all 6 to get to 8 below? Basically, you're more than halfway to 8. So it's easier to gain 2 electrons than it is to lose 6. So to make the ion, we're going to add 2 more electrons. And now it has full 8. To show that you've done that, you now have to put a square bracket around it and put the charge. You gain 2 electrons, so it's 2 electrons gained. We put 2, and minus, because each electron is negative. And if you think about it, that makes sense. You now have 18 electrons. And you still have 16 protons. The proton number and neutron numbers don't change. But what that means is you have 16 positive charges and 18 negative charges. You have 2 more negative charges than positive charges. Before that, you had 16 protons, 16 electrons. They cancel out. They have the same amount of positive and negative, so that canceled out. It was not charged. But now it is charged. You have an anion. So to make sulfur, sulfur requires 2 electrons in order to form a stable octet. So you add 2 electrons to form 2 minus. So this, to represent this, you could also write S2 minus. This means that you have sulfur with a charge of 2 minus that it gained 2 electrons. Whereas here it's just regular S. So to find the number of electrons in sulfur 2 minus, you look at the number of electrons that sulfur would normally have, 16. And because it says 2 minus, that means that now it has 18 electrons. It gained 2 electrons on top of the electrons that it already has. Okay, let's try our next one. So you can try this one as well. Try to guess which element you have. Again, look at the number of protons. So if you look at the number of protons, there's 11. So if we go to atomic number, we're dealing with sodium. So sodium has 11 protons. And right now, the way it's drawn, there's 2 on the first, 8 on the second, and then 1 on the last. So there's 11 electrons as well, and there's a charge of 0 because they're balanced. Now, if you were to form the ion, the proton number stays the same, 11 and 12. You look at the last shell and you ask yourself, is it easier to gain 7 to get to 8, or lose this one to get to 8 below? You're not more than halfway to 8, so it's easier to lose 1 right now. So it's easier to lose 1 than gain 7. So the ion will be drawn like this. We draw the first shell again, we draw the second shell again, but we're not going to draw the third shell because we lost that 1 electron, so it's gone. So because we lost 1 electron, we're going to put square brackets, and we're going to put 1 plus, because we lost 1, and it's now positive by 1. And so now we still have 11 protons, but now we have 10 electrons because we lost 1. So if you think about it, this makes sense. We have 1 more positive charge than negative charge. So that's why we're positive 1 at this point. You can represent this by Na with a little positive on top. You can put 1 plus or positive. And here, this is simply Na. This is neutral Na. And this is positive Na. So, as we discovered here, we had the Bohr-Rutherford diagram for sodium at first. Sodium had 11 protons based on the periodic table, its atomic number. For the ion, once it's drawn, we have 10 electrons because we lost an electron. Because it's positive, you know it's a cation, and we know the symbol is Na, 1 plus or plus. And so in general, that's how you determine what charge an ion would have. You ask yourself, is it easier to lose or easier to gain electrons? If you're more than halfway towards 8, you gain. So nonmetals gain usually because they're more than halfway towards 8 in their valence shell. If you're less than halfway, you lose. Metals usually lose. The usual trick that you use, though, for your periodic table is you take a look at the groups. Remember, group 1 has 1 valence electron, so it's going to lose 1 valence electron. Group 2 has 2 valence electrons, so it's going to lose 2. You skip these ones, and you go to group 13. Group 13 has 3 valence electrons, so it's going to lose 3. Group 14 has 4, so it's kind of halfway, so we don't really see ions with that too much. It does different things. Group 15, that has 5 valence electrons, so that means that we're more than halfway, so we'll gain 3. Group 16 has 6 valence electrons, so we'll gain 2 to get to 8, right? Group 17 has 7 valence electrons, so we'll gain 1 to get to 8. And group 18, so let's take a look here. You'll notice in all the groups, we can see charges, right? And those charges kind of told you how many electrons they have to lose, or here, gain, if it's minus. But you'll see there's no charges in the noble gases. So why do you think that is? That's right, it's because they already have a full valence shell, so they're not going to lose or gain. They already have 8 valence electrons, except for helium, which has 2, but remember it's its first shell, so it's already full. So here we learned how to draw ions and figure out their charges using the periodic table. In the next video, you can watch the next video, which is the answer key to this practice page here. So I want you to try out drawing Bohr-Rutherford diagrams for magnesium, the magnesium ion, fluorine, the fluoride ion, and then we'll take it up in the next video. We'll also take a look at ionic notation and isoelectronic species as well.